Welcome guys again to my YouTube channel. Today we're going to be doing a very interesting Euclidean geometry question. And then so we are given PQ, which is a chord, right? And we have a center M, okay? And then which tells us that MQ is a radius because the line from the center to the circumference. And then we have PQ, which is produced to R, and then such that our QR, right, is equal to 2PQ. So this 2R, QR, is equal to 2PQ. Then we have T is the midpoint of PQ, which means that PT is equal to TQ. And then in the context of this question, it can also mean that our TQ is equal to half PQ. And our PT is equal to half PQ, right? Because this divides the line PQ into two equal parts. Meaning that this is going to be half of PQ, this is also going to be half of PQ. And then they say that we must prove that MR squared is equal to MQ squared plus 3 over 2 QR squared. Whoa, what's happening? So now another thing which we can see is that since we have a line from the center to the midpoint of a chord, we're going to have a 90-degree line here. So now, what are we going to do? The first thing which I notice is that I have a 90-degree triangle, which means that I'm going to have to use Pythagoras. I have this big one, and I also have this smaller one. So this can help me in some sort of a way. And then that means that I have a proportion here, 3 over 2, which means that also these proportions which they have given me, in some way, they are going to help me, right? So now, what do I think of doing then? I notice that I have an MR squared, and then I have an MT squared over here is equals to a TR squared. So now, what I do notice is that there is a way such that I can express this whole line as QR. And how can I do that, you ask? So basically, what you can see is that we have QR equals to 2PQ, right? And then this means that our PQ is equals to QR over 2. And then I've told you that TQ is equals to half PQ, remember? And this must mean that my TQ is going to be equals to 1 over 2 into QR over 2. And this is going to be QR over 4. Isn't that amazing? So this is the same thing as 1 over 4 QR. Like that. So that means that if I have my TQ as 1 over 4 QR and I have QR over here, it means that I can express the whole line TR as in terms of QR, because it's going to be 1 over 4 QR plus QR, like that. And now that's one step of the solution. So now let's do this. Let's continue with the problem until we get stuck, right? I'll just do the first thing which I see that I can do. I see that I can do Pythagoras in this big triangle, and I said I can do Pythagoras also in this smaller triangle. And then so you can start in any other way in which you can do your Pythagoras, but I'm going to start with the Pythagoras in the bigger triangle, right? Just so that we see where we are going. So we have our mr squared. Before I start this is how I'm going to write it. So up there I was just explaining, and now I'm getting to the writing. Sometimes you may know how to solve a problem, but you may not know how to write it, which makes you to lose marks. So you have to know how to express your ideas in a logical and mathematical manner. Okay, and then so what we have seen first is that our MTQ is equals to 90 degrees. And why was that? Where the line from the center to a midpoint of a chord, right? Like that. And then what we are going to do now, we are going to say that our TQ is equals to half PQ. Why? Because T is the midpoint of PQ, right? And then we are going to say that since QR is equals to 2PQ, therefore PQ is equals to QR over 2. And this, therefore, this TQ over here, because it's equals to half PQ, and PQ is this, therefore my TQ is going to be equals to half into QR over 2, which is equals to QR over 4, because you have 1 times QR, you have 2 times 2. Okay, and then we can say that TR, right? TR is this whole line over here, is equals to TQ plus QR. And we have our TQ is QR over 4. And my QR is QR. And we want to add these, right? So if we're going to add these, that means that here we're going to have QR over 4. And to make the same denominator, I'm going to multiply by 4 over 4. These cancel out to still give us QR. And then therefore my TR is equals to 5 QR over 4. And then we can now do our Pythagoras theorem. So now we have mr squared, right? The hypotenuse equals to mt squared plus tr squared. Pythagoras. And then my mr squared is equals to my mt squared plus my tr, which is 5qr over 4 all squared. Therefore my mr squared is equals to mt squared plus, this is the same thing as 5 over 4 qr, right? and this is going to square this, and then it's also going to square this, right? Which means that my mr squared equals to mt squared plus 25 over 16 qr squared, because 5 squared is 25. Yes, because 5 squared is 25 and 4 squared is 16. So we compare with what we have over there. We have an mq squared and a 3 over 2 qr squared. Okay, then I think if you notice on the diagram, you see that my mq squared, which is this one, is equals to mt squared plus tq squared. And then the mt squared is this mt squared. So meaning that there is some way in which I can remove this mt squared and sum of the coefficient of the qr squared such that I will have what I am supposed to prove. Okay, so then what I'm going to do now is that I'm going to go to the second triangle, which uses MQ. So forgive me for that. So I actually noticed that my MQ squared is equals to MT squared plus TQ squared. And the reason being Pythagoras. But then we know that our TQ is equals to QR over 4, right? Over here. So therefore, my MQ squared is equals to MT squared plus QR over 4 all squared. Why? Because my TQ is equals to QR over 4. And this is going to be MQ squared equals to MT squared plus QR squared over 16. This means that my MQ squared is equals to MT squared plus 1 over 16 QR squared. And let me call this my equation 1. So now, do you actually see here that my MQ squared is equals to this MT squared, which is over here, plus 1 over 16 QR squared. And then, so what I want you to notice is that if we let this be equation 2, I can say that from my equation 2, MR squared is equals to MT squared plus. So now look at my 25 over 16 QR squared. I can split it into 1 over 16 QR squared plus 24 over 16 QR squared. Wow. Isn't that amazing? I'm kidding. But then, yeah. So now what you see is that here you have that mt squared plus 1 over 16 QR squared. And you have mt squared plus 1 over 16 QR squared, which is equation 1. So if I let this be equation 3, then I'm going to substitute my equation 1 in 3, meaning that I'm going to replace this whole thing with what it is equals to, which is mq squared. So therefore my mr squared is going to be equals to mq squared plus, so mq squared plus, so if you simplify this fraction, is going to be 8 goes in 24 3 times, 8 goes in 16 2 times. So if you divide by 8 on the numerator and denominator, you get 3 over 2 QR squared. And voila, you have the answer which is given in the question there. And with that said, guys, thank you for watching. Don't forget to like, comment, and subscribe.